Hello, my young friends. I am Javashri Ghosh, teacher in Demonstration Multipurpose School. My dear children, I welcome you to my science class. Children, it's quite unfortunate that you people are not able to go to your schools, meet your friends, meet your teachers. Even we teachers miss our students. But don't worry, children, we have a way out. We are trying our best to reach you. Children, today get ready to learn and enjoy the first chapter of your book, class 9th, Matter in Our Surroundings. So, children, get ready with your notebooks and pen. Let's start. Okay? What is matter? As you know, children, our universe, Earth comprises of lots of things. There are lots of things surrounding you. There are human beings, there are animals, trees, air, water, your TV set, your chair, table. You are surrounded by lots of things, is not it? And you know these objects, these things, as a scientist, they call it matter. Okay? This matter, they have some mass. You know mass? Yes. Even they occupy some space here. That is, they have certain volume, is not it? So, children, matter has mass and matter has volume, that is, it occupies space. Now, when scientists, they have known about matter, now the next part comes, what is the matter made up of? Or what is the composition of matter? You know, one group of individuals, or you can say intellectuals, they said matter is a continuous thing, like a block of wood. But another set of individuals, they argued, no, matter is not continuous. Matter is made up of particles, just like sand particles. But children, science doesn't go for argument. Science needs proof. Science needs experiments and their conclusions. So, let's do certain activities, children, to know the composition of matter. Okay, children? I have this glass of water with me. Now, let me add some salt to this. See, I have taken some salt and I am adding to this. Now I am stirring this. You see, children, the salt is getting dissolved. I have also put a mark before adding the salt. Now you see, when I am continuously stirring this, after a few minutes, see, can you find the salt? Is the salt visible here? Where did it vanish? No, it didn't vanish. It is certainly here, is not it? Let me taste it. It's so salty. Means salt is inside this water. Where did the salt go? Children, just think. I have added certain amount of salt to water. Where did it vanish? Did it really vanish or it's there inside water? When we dissolve salt in the particles of the salt, get into the spaces between the particles of water. Particles of water are there, particles of salt get mixed into it. So, we have done one activity. What do you conclude? The conclusion is matter is made up of particles. We have given proof to this. We have shown the particles of salt are mixed or intermixes with the particles of water. So, matter is made up of particles. Now, let us show how big, how small, how tiny, how large are these particles. Okay? Suppose children, I take here 80 ml of water. Okay? Here in this container, I have potassium permanganate. When potassium permanganate dissolves in water, it gives a beautiful color. Let's see. See children, what is the color? We got a lovely color of potassium permanganate. It is dissolved here. So, when I stir it, can you see the beautiful color, dark violet color I have got? Now, next what am I going to do? Here in these 4 beakers, I have 70 ml of water in each. What I want to do is, I want to go on diluting this potassium permanganate. I have a measuring cylinder that is 10 ml. Okay, this measure is 10 ml. What I do, from this I'll pour 10 ml of solution over here. Okay children, see you. Then I dilute this by putting in 70 ml of water. What do you see children? Yes, we have a dark pink color, lighter than this, but still we can know this is the solution of potassium permanganate, is not it? Now again I am going to dilute it. See here. Here also light pink color, we have a bit lighter shade of pink. This shows that, what do you conclude? Yes, still there's potassium permanganate in this, is not it? Okay. Let's go for the next step. See here children, in the next step I put here. Here also traces of pink is there. Pink traces are there. It also shows that still after diluting several times, we are getting traces of potassium permanganate in this solution. Now children, can you just imagine, I had used a bit of potassium permanganate, and here also in the last stage also we are seeing traces of this. So what happens here? On dissolving potassium permanganate in water and on diluting it several times, we still find a colored solution. This shows that there must be millions of tiny particles in just one crystal of potassium permanganate, which keeps on dividing themselves into smaller and smaller particles. Yes, this was an activity. And children, so what is the conclusion? Our conclusion is that particles are very small in size. They are tiny particles. Matter is composed of tiny particles. So children, we have matter is made up of particles, and that too the particles are very, very, very small in size. Okay? Next, we are going to learn what are the characteristics of particles of matter. Characteristics means properties. Here we'll describe or we'll learn about the physical properties of matter. Children, you have seen that in my previous activities, when I had mixed salt in water, when I have put some potassium permanganate in water, what did happen? This potassium permanganate, salt, they got evenly distributed in water. Is not it? You see, can you see the traces of salt here? Can you see the traces of potassium permanganate? No. This shows that there is a lots of space between the particles of water which accommodates particles of salt or potassium permanganate. We have water. Water is made up of particles and salt is also made up of particles. Similarly, water is here also, potassium permanganate is made up of particles. Now what happens? Particles of potassium permanganate or salt mixes with the particles of water and the traces are not found. So, what do we conclude from this activity? We conclude that the particles of matter have space between them. Since they have space, they can accommodate other particles also. Okay, children? Now, children, I want to show you a beautiful activity. Okay? Let me take some water. Okay? On putting a drop of colored ink in glass of water, we see that the color spreads throughout. This we can carry out here also. Let me have ink. Okay. Let me put the ink over here. Just see how it spreads. Just look at the glass. How lovely color. How it's spreading. The ink is spreading here. Okay. And one thing you can see, they're continuously in motion. This water and ink both are trying to intermix with each other. Particles of water is in motion as well as the particles of ink is in motion. This intermixing of these particles of ink and water is termed as diffusion. What is it? It is diffusion. Intermixing of particles, see here how lovely they are mixing. Intermixing of particles of ink and water is termed as diffusion. Okay. Even we have seen diffusion in here also. See, it is also diffusion. Here I have used ink and here I have used potassium permanganate. In both the cases, diffusion occurs. What is diffusion? Intermixing of particles of matter on their own. I am not stirring it. It is mixing by itself. Is not it? Children, so from this we can conclude particles of matter are continuously moving. Here particles of water is moving, particles of ink is moving. Here particles of water is moving, particles of potassium permanganate is moving. Okay, children. As you know, when in a matter, the particles inside the matter are moving continuously. Okay? Due to this movement, they gain certain amount of energy. That energy which is possessed by the particle due to the motion is termed as kinetic energy. What do we call it? Kinetic energy. Suppose I want to give you an example. Let me give you an example. Many of you children might be participating in sports is not it. Running, jumping, high jump, long jump is not it. Yes, children, they do. Those who go for the long jump competitions, what they do? When they start, do they jump from the marking line on the sand? Have you ever observed? No, they don't do that. What they do? They start running from a certain distance. You can say 20 to 30 meters or more than that even. Why do they run from certain distance and then jump from the mark? So that they can jump to a longer distance. Why? While running, children, they gain some energy. When they are in motion, they gain some energy. And this energy is termed as kinetic energy. And due to this energy, they can jump a longer distance. Similarly, in case of this matter also, particles, while moving, they gain some energy, and that energy possessed by the particles is termed as kinetic energy. One thing let me tell you, when the particles gains kinetic energy, what happens inside the matter? When energy is there, they will move apart from each other. That's not it. So, the particles also gain speed and they try to move apart from each other, creating a space between the particles. Okay? And what happens? When the temperature rises, means it's hot. What happens when the temperature rises? The kinetic energy of the particles increase. Kinetic energy of the particles increase means they gain speed, they move apart from each other, okay, and they create space for other things. With the increasing temperature, the kinetic energy of the particles also increases. I'll just give you one example from your day-to-day life. Now it's summer, is not it, children? And you want just cold drinks for yourself. If cold drinks is not available, you can make the lemonade also. What you do? Have you ever tried by taking ice cold water and dissolving sugar in that? And on the other part, you have tried dissolving sugar in a cup of coffee or tea. So children, try at home by mixing sugar in ice cold water and sugar in your hot coffee. Okay, now just see in which sugar dissolves faster. So with the rise in temperature, the movement of the particles increases. Energy possessed by the particles due to its motion is called kinetic energy. Energy of particles increases with the increase in temperature. Children, I have got one thing for you. Let us start doing one experiment in which you can conclude what is the property. See here, children, I have a piece of chalk. I am able to break it without any problems, easily, so to say. Here I have a iron rail. This is a nail. Okay. Now, if I try to bend it also, it's not possible for me at least. I'm not able to bend it. But this is a wire. Okay, children? If I put a little bit of force on this, what happens? I am able to bend this. Okay, children? I'm able to bend this. There are different examples I'm showing you. You can conclude what is the difference in all these things. See here, children, you know what is it? Yes, it's a rubber band. Rubber band, see here? And what I do with this rubber band? I can stretch it and I leave it. Okay? I can play with it. Children, there are certain things I'm able to break it easily. There are some other things which I tried but I could not. Why? What is the difference? Children, the difference is that the particles of chalk, the particles in the chalk are bit loosely packed. When I apply a little bit of force, it breaks. Okay? But in the particle, suppose I take this spoon, I apply the force, it doesn't break. The particles in the spoon or the iron nail, what happens? The force of attraction is greater. So particles in matter are held together by the force of attraction. Okay? They're held together by a certain force, and that is the force of attraction. Particles of matter attract each other. Now, just give a thought. A diver when jumps into the pond, river, wherever, or the swimming pool, what happens? How does it swim? It just moves like separates the water and then goes forward, is not it? Which property of matter does this observation show? It's for you to think. Which is easier to break, nail or chalk? That I have shown you. And you just tell me why. Now children, matters can be classified. Okay? We can classify or categorize matter. What is the basis of classification of matter? On what basis we can classify the matter? See here, matter into solid, liquid and gas. On what basis they are classified? Based upon the particle arrangement. You can see the differences in this figure. The classification is also based on the energy of the particles. I've talked about the energy of the particles. Then, based upon the distance between the particles that you are able to see on the screen also. So, states of matter are solids, liquid and gas. Solid has fixed shape. It has a definite volume also. Liquid has no fixed shape, has definite volume. Gas has no fixed shape, neither it has a definite volume. Children, apart from solid, liquid and gases, we have two more states of matter. That is the plasma state and the Bose-Einstein condensate. That part we'll discuss in the later half of this chapter. Okay, we won't go deep into those things, but you should know that we have two more states of matter. Now let's discuss this one by one. See here, solid state. What is this? Solids are rigid. Why rigid? I'm trying to break this. If I try to break this table, then what happened? I'm not able to break it. I need a karate man to break this. If I also try to break this toy, I'm not able to do this because it's rigid. Okay. Solids are incompressible. I'm not able to press this solid. Am I? Am I able to press this solid? This is also a solid. You can say this is also a solid. Okay. Am I able to press this? No. I'm not able to do this. It is incompressible. Solids have definite shape and volume. This is a solid which has a beautiful cubical shape and even volume. We can find the volume of a cube. We have seen that solids can be broken or deformed by application of force. This is a solid wire. It can be deformed. See here, I am applying force, I am deforming it. Or this is also a solid, unable to break it. Okay. But one thing I want to show you, children. This is sugar. Okay. This is what is sugar. Sugar is solid or what? Of course it's solid. Is not it? Now, we know that solid can be poured, but they are solids. We know liquids can be poured, but what about solid? Let me do this. I am pouring this solid into this katori. What happens? The solid has taken the shape of the katori. Does all solid do that? No. But when I have poured sugar in this katori, it takes the shape of the katori. If I put the solid somewhere in this glass, it will take the shape of the glass. So, this sugar is solid or not? Children, it's solid. Because every grain of sugar that has not changed this grain of sugar that has not changed its state. It is rigid. It is incompressible. The bulk, okay, it takes the shape. It can be poured. But one grain, it has not changed its shape. Okay, children? One thing we had discussed, solids are incompressible. I'll show you one thing. What is this, children? This is sponge. What is the state? Yes, it's solid. When I compress it and then release the force, it comes back to the original shape. So, sponges are solid. Solids either do not diffuse or diffuse very slowly. Solid-solid diffusion is rare. Solids have more density. What is this density? Density is mass per unit volume. I have certain questions for you. And children, remember, note it down and take it as task. Do it. Rubber band changes its shape. Is it a solid? Sponge can be compressed. Is it a solid? Arrange the following in the increasing order of the force of attraction between the particles. Air, sugar, oil. Juice, wind, salt. Which is denser, 1 kg of cotton or 1 kg of sand? Children, give a wild thought and write down, try to find the answers. Next, children, let's go to the liquid state. Liquids are not rigid and can flow. If I drop some water on the table, what's here? I'm dropping, it is flowing. It doesn't have a definite shape. It takes the shape of the container in which it is put. Liquids are almost incompressible. Liquids do not have definite shape, have a fixed volume. Solid, liquid and gases can diffuse in liquid. I have shown you. We have diffused potassium permanganate in liquid. We have diffused ink in all liquid. They can diffuse easily. Even rate of diffusion is more in liquid as compared to solid, because in liquids the arrangement of particles is not that closely arranged as in solid. They're a bit loosely arranged. Particles in liquid have more space between themselves as compared to solid. Now comes the gaseous state. Gases have tendency to flow, hence gases are also called fluid. We say gases can also take the shape of the thing in which it is put. For example, let me show you. I have a balloon. This is a sort of round balloon. Okay? When I have filled the gas and it is filled, it seems the gas is round in shape. Here gases is filled here. It takes the shape of the balloon. Whereas, when the same amount of gas is filled here, is take the shape of a heart shape. So, gases, they do not have fixed shape. They take the shape of the container or the thing in which they are filled. Okay? Gases are highly compressible. We can compress the gas, as in case of bottled, like gases, LPG, CNG, oxygen, they are bottled. Why they are bottled? In those cylinders, we can fill large volume of gas and they can be transported easily. Particles of gas have larger space between them. We cannot say the cylinder is half filled. Why? Think. Gases diffuse very fast due to the high kinetic energy of its particles. Children, suppose you are in your study and a tempting smell comes from your kitchen. You run towards your kitchen. It's not it to see what delicious food is there. When the hot, delicious food is being cooked, you get the aroma very quickly. It's not it. How do you get this? This is just diffusion of the aroma with the air, and that reaches you very fast. But do you ever get the smell of cold food that fast? No. When there is rise in temperature, diffusion is also more. So you get the odor or the smell of the cooked food, that is hot food, faster. Even incense sticks you have seen? When those are burnt or lighted, the gas, the smell, you get it very quickly. It's not it. That is diffusion. And gases diffuse in water very quickly. You know, children, due to this diffusion of gases in water, what happens? Lots of aquatic creatures, they're alive for this. The aquatic creatures will stay in water. They respire with the oxygen mixed in water. So, due to this diffusion, they're able to sustain life. Density of gas is minimum as compared to solids and liquids. Children, I've got few questions for you. You have to think because I have discussed those things. Ice being solid floats in water. Why? Let me give you a bit of hint for this. Then you can write your answer. Ice is a solid and we know that solids have more density than liquid. Is not it? But in case of ice, what happens? The volume of ice is 9% greater than volume of water of the same mass. Okay. So, the density of ice is greater than density of what? Water. So, ice floats on water. Is less, and so ice floats on water. Even, children, we have lots of type of wood also. The wood seems it's more denser, but no. Wood also floats on water. You try it at home. Gas exerts pressure on the walls of the container. Why? As I have told you, when the kinetic energy of the particles increase, they move here and there in the random motion. When they move here and there, they strike each other and even they strike with the walls of the container. Okay. So, due to their motion, they strike the walls of the container and the pressure on the walls also increases. Why does honey diffuse in water at a slower rate than ink? If I put a drop of honey in water, it diffuses. See, the diffusion is slow as compared to the ink. It doesn't diffuse so fast. We have to stir it. Okay. Which property of gases help us to detect the leakage of LPG gas? How do you know that LPG gas is leaking? Yes, when it's leaking, what happens? You can smell it because it diffuses with the air. A balloon kept in sun burst after some time. Why? Suppose I keep this balloon in sun. After some time it will burst. Why? Let me give you a hint. The particles inside the balloon, due to the increase in the temperature, they gain the kinetic energy. The speed also increases. Okay, when the speed increases, they exert pressure on the walls of the balloon. And balloon tries to expand, and ultimately what happens? Children, till now what we have studied, let's summarize it. Differences between solid, liquid and gas on basis of certain characteristics. Shape, volume, force of attraction, interparticle space, rigidity or fluidity, compressibility. I think this chart will help you to remember things in a better way. Children, this is all for today and wait for the next class. I think you have enjoyed this class. You have seen all these things and I think you have learnt a bit. Now what to do next is take out your book, read it thoroughly and try to answer the questions that I have given. Okay children, take your own time, stay home, stay safe.